Hello everyone, welcome back to the channel. Today we are going to start a Python coding interview question series. Just like we had SQL series, we saw a lot of complex and company based and commonly asked questions. In this series also, similar thing we will do for Python. Okay, so today what we will do, I want to discuss three things in this video, right? First thing is what you will expect from this series, Python coding interview series. Second, we will talk about what are the prerequisites, right? What all you should know to start following this series and start practicing Python questions. Third thing, we will talk about some of the important things like time complexity. I want to make sure that you understand what is time complexity so that when we solve questions, right, we will solve questions with brute force method or optimized method. That time we will talk about that, okay, this is the time complexity with brute force method and this is the time complexity with optimized method. So you should be able to understand it, right? When I sort the data, what time complexity it is, right? So those basic things we will discuss today at the end of the video so that you are ready for the interview question series. Okay, so let's start with the first thing, that what you will expect. So we will take commonly asked questions as well as the company based questions. For example, the question which was asked in Meta or Amazon or Tradance or Fractal or Infosys, right? Different companies. And we will solve all levels of questions like easy, medium, hard, all level of questions we will solve. Now for each question, wherever applicable, we will solve using the brute force method as well as the optimized method so that you make that thinking that how to go about optimized solution, right? How you can approach a question first with brute force method, what are the problems with brute force method, and then how I think about optimization, right? So all those things we are going to discuss in this series. Okay, so you should know some basic things, right? For example, as part of Python, right? The core Python, you should know variables, loops, if else conditions, right? You should also know different kind of data structures like list, you should know dictionary, tuple, right? How you run a loop over these data structures, right? So those basic things are only prerequisite, right? If you don't know those things, please start learning those, right? In the world of AI, without Python you cannot survive now, right? If you know Python, you can do a lot of things. It will be easy to learn AI as well, right? And typically for data analyst and data engineer interviews, we have SQL and Python as first round, right? So if you are preparing for interviews, this becomes a must have thing. So what you should do, learn these basic things and then you can follow along with me and practice questions, right? We may solve questions on local system or on different platform. We will see, right? Wherever we get best questions, we will solve there. So we are not restricted to one platform or a local system. We will solve wherever we get the good questions. Okay, great. This will be focused on mainly data analysts and data engineers, right? We don't want to learn very advanced algorithms or advanced things which are useful for SDs, but for data roles, I don't think those things are important. We will focus on only data roles, data analysts and data engineers. Great. So I hope you got the idea what we are going to do it. And now what we will do, we will learn about time complexity and some of the concepts that will be useful throughout this series. Okay. So let's go to the system and start it. Okay, so let's understand what is time complexity, right? Let's read the definition and then I will break it down step by step. So, time complexity is a way to measure how the number of operations in an algorithm or program, you can write anything, right, grows as the input size increases. It does not represent actual time taken, but how efficiently an algorithm scales. It helps compare algorithm independent of machine speed or programming language. Now, a lot of people think that time complexity means the time taken by a program, which is wrong because time taken by a program is dependent on machine, right? If you are running a Python program or any program on, let's say, 8 GB machine, it will take some amount of time. But if the same program you run on, let's say, 16 GB or 32 GB machine, then it will take less time, right? So that time taken by a program is not fixed. It is dependent on machine. But time complexity we measure independent of machine, right? It does not represent actual time taken, but how efficiently an algorithm scales, right? So this thing should be clear, right? That time complexity is independent of a machine speed or which programming language we talk about, right? We just a relative measure to check how good my program is. So we will understand with a simple example first, right? So let me move on to Visual Studio, and I'll explain in a very intuitive way. Let's say you have this array, right? Array or list. In generally most of the programming languages, you say array. In Python, it is a list, right? List is a group of elements together, right? So we have one, two, three, four, five, six. Okay. So this is my input, right? This is my input. This array is my input. Let's say I want to find sum of all the elements of this array, right? So what I have to do, I have to start with this, then go to this, then add this, then add this, then add this, then add this. So if there are six element, I will have to do six operations, right? So let's write a program. So let's say my sum is, or let's define a function, define get sum, right? And it will take one array as input, right? So what we will say, we will initialize my total sum. So I will say total sum equal to 0. Right. Now I will run a loop over it, right? Because I want to go to each element. So what I want to do, I want to run a loop over this list, right? I want to go over, iterate over this loop and go to each element and sum all the numbers. So I will say for num in, right, add, and then I will say total sum, right, equal to whatever was sum was there earlier plus this num, whatever num I get, right? So I'm getting 1, 2, 3, 4, 5, 6, right? And I will just run over it and then I will say return my total sum. I hope you understand this. So I want to see how many times I'm doing this operation, right? So I'll say print and I will just call this function now. So I'll say get sum and I will pass array, this array, whatever we have declared here, right? And let's see. Okay, so it is giving me 21. So if you sum all of this, it will give you 21. Now, how many times we are running the loop or how many times we are doing this operation, right? So let me print it. So I will say iteration. We will see how many iteration are there. Iteration equal to 0, right? And then in the loop, I will say iteration equal to iteration plus 1. Then I will say print iteration and then iteration. Right? I'm just showing you how many times we are running this loop. So if you see iteration 1, 2, 3, 4, 5, 6, right? So there are six elements. I'm running this loop six times. So I'm doing six operations, right? Let's say if I increase one more element here, right? So how many times this will run? Seven times. Which means as the size of my input is increasing, the number of operations are increasing linearly. Linearly means if there are eight elements, then number of operations are eight. I am doing eight operations. If it is nine, then nine operations. If it is 1 million, let's say in this area I have 1 million elements, then I will run this loop on 1 million elements and there will be 1 million operations, right? So this is known as a linear time complexity. We represent time complexity by big O notation O and then N. Right? So this is N means linear time complexity. As you increase the size of the input in the same proportion, your number of operations will increase, right? Now it is irrespective of machine, right? The way we are calculating this complexity, big O N, is irrespective of machine, right? We are saying as the number of input size is increasing, is the number of operation increasing? Now it will be true for 8 GB system or 16 GB system or for Java or Python or any language, right? So this is why this is platform or program and speed independent, right? This is how we calculate the time complexity. Great. So if I go back here, it is saying ON is linear time, right? So our example is loop over the list. So you can draw a chart, right? So if you see this chart, so on the x-axis, I am saying input data size, right? As the size of the input data increasing, how the number of operations are increasing. So in case of linear time complexity, right, ON, this is linear. So as the input size increasing, in the same manner, my number of operations are increasing. So if you see, this is x equal to y, right? The number of input data size equal to number of operations. So this is the x equal to y line on your chart, right? So this is your ON, right? Lesser the time complexity, better your program is, right? Now let's take another example. So this we understand. Now let's say my requirement is I want to get the first element of my array. So this is my array, right? Let me just comment this. So this is my array and I want just the first element of the list. So what I will do, L and first element will be 0, right? And I will print this. So let's print it. Okay. So if you see, I am getting 1. So this is giving me the first element. Now let's say I increase the number of elements in my array, right? Now if I again done this, I'm always doing one operations. It doesn't matter how many elements are there in my list, right? The number of operations will be just one, get the first element of the list. So this is known as constant time complexity, that the time taken or the number of operations done by your program is fixed irrespective of how small or big your input is, right? So this is known as O1. It will take fixed O1 time. Right? So this is your constant time complexity where it is constant irrespective of input size. And if you look at the chart, this is my O1, right? This is flat. Doesn't matter that how big is your input data size. If we keep increasing, the number of operations is constant, which is 1. So there will be only one operation. So this is known as constant time, accessing an index in the list, right? So this is your O1, ON. So O1 is better than ON, right? Because it will just one operation, right? So always if you go up, it is the worst time complexity, down it is the best. So O1 is best and after that ON. We will talk about other time complexities as well, right? Now let's take another example of ON, right? Let's say I have this array now, right? Now, what I want to do, right? This can be a sorted or unsorted array, right? Let's not take it sorted. So let's take it 15, 11, 12, something. Okay. Now, what I want to do, I want to find index of a particular number, right? Let's say someone is tell me where is 15, right? On what index 15 is there, right? So my target is this, that I want to find index of 15 in my list. So how I will do it? Let's write a program. So I will say def find index, right? It will take two input. One is array and another is target, right? What you want to search. This is also known as linear search. So I'll just explain about it. So what I'm saying, that okay, loop over it and check wherever the target is. So I'll say for, let's take I in range, right? These things you should know already. Length of array, right? So I'm saying if li, right, is equal to target value, right? Whatever target I have, then return that index value, right? That's it. So this is my linear search. You can call it linear search. I'll tell you what is linear search. Linear search. Okay. Now we will see what is the time complexity of this. Okay. So now I will just call this, I'll say linear search, and let's call, I'm passing array, right? And my target, right? Great. So let's print it. So target is 13. The target element, let's call it target element, and I'll just pass this here. Okay, let's see what it will give me. Okay, so it is giving me 9, right? 9 means, so if you count here 0, 1, 2, 0, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So it is at ninth index, right? So the 15 is at ninth index. Now let's say I search for 7. So so it will give me where is 7? 7 is at sixth index. Great. Now let's say how many iterations we are doing here. So again, we are running, we are comparing this. So this is one operation, right? We are running this inside for loop. So I will say iteration equal to 0, right? And then iteration equal to iteration plus 1. And I'll just print iteration. Okay, let's run this. So if you see, this is running 6 iterations, right? Uh, da, 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 da. Okay, it has to be outside the loop. My bad. Okay, so initialization is outside the loop, and then okay, it has to be outside actually if condition, because only it will print only when we satisfy the condition, right? So iteration equal to iteration plus 1. Great. Uh, okay, print is again here. So let me just fix this. Okay, so if you see 1, 2, 3, 4, 5, 6, 7, so it is running 7 times, right? So now if you see, the number of operations is dependent on where my element is. If I just, let's say, search for 2, right? So it will run only 2 times. Iteration 1, iteration 2. So there are only 2 operations, right? Now how I will tell what is the time complexity, right? Time complexity depends on that which element you are searching. If you are searching for 2 here in this list, then it is at second element only 2 operations, right? If I search, let's say, 11, then it will run maybe 8 or 9 times, right? So when we talk about big O notation, we consider the worst time complexity. Worst means if someone is searching 12, that is the worst case, right? When someone is searching 12, that time we have to run over the full list, right? So if I run this, it is running 12 times, right? So when I talk about a big O notation, it means we are considering the worst time complexity. That at the worst, how many operations I have to do. So again, this is a ON, because if the number of elements are increasing, if it is 15, then my worst will be one more operation. Right? So it is running 10 times. If I increase one more, right, let's say 20, and again, so it is again 10 times, right? So it is running 10 times. If I make it 20, this is my worst time complexity, which will be 14, right? We have to go till here, right? So whenever you think that what is the time complexity of this program, you have to take the worst case. In best case, it will be O1, right? Because maybe every time you find the first element, right? Someone is searching 1, right? You will get in the first iteration itself. But you have to consider the worst time complexity, and in this case, it will be ON, right? So this comes into the category of linear search, that we are searching a element linearly, right? Linear means first element, then we check second element, then third, then fourth, then fifth, then sixth, and so on, right? So this is your linear search. Great. Now let's move on to the next time complexity, right? Which is, let's talk about ON square, right? Then we will move on to the log n. So what is ON square? Quadratic time. Generally, when you have to run the nested loops, right? Loop over loop, that time this quadratic comes into picture, and it is very bad kind of time complexity, right? Because as the input size increases, your number of operations will increase square of times, right? So for example, if you are increasing from 10 to 11, then maybe your operations are increasing from, let's say, 10 to 100, right? I'm just giving one example, right? So let's understand that. So I have written a simple program to find a duplicate transactions, right? So let's say you have a this transactions, you have a array, right? And then what you have to do, you have to find the duplicate transactions. So what I have to do, for example, 101, 101, these are duplicates. So I have to get the index of these. So let me run this and show you. Okay, so I'm getting answer as 0 to 14. So it is telling at index 0 and index 2, they are duplicates. Similarly, at index 1 and index 4, they are duplicates, right? So this is what it is returning. List of tuples. Great. So let's think about it. How do we solve this problem? So what I have to do, I have to pick first element with a very brute force method, right? First element and compare with all the elements, right? So 101, 203, 101, 404, 203. So this element I will pick and compare with all the elements. Then in the second iteration, I will pick this element and compare with all other elements. In the third iteration, 101, and then I will compare with other elements, right? So this is what we have to do. So this is a loop under loop, right? So this is a nested loop. So I'm running a loop on this list first. So if you see on transaction, and then again I'm running on the another loop on transactions and comparing, right? I'm not going to explain this program, but basically we have to run loop two times, right? Whenever you see two times loop, mostly it is a o n square time complexity, right? Let's see how many iterations we have to done. So I'll say iterations equal to 0, right? And we will say iteration equal to iteration plus 1. Now I will, so all the operations we are doing inside the second lasted loop, right? So I have to print here, right? So for every element in outer loop, inner loop will run, right? So all the operations are happening within the inner loop. Let's say iterations plus 1, and let's print it. Print iteration. Great. So if you see, I'm doing 10 iterations, right? I'm doing 10 iterations for this program. Now let's increase the size of my transaction. Let's say I increase one more, let's say 100. Now what will happen? In each loop, I have to iterate one more time. So when 101 was comparing, it was comparing with four elements. Now it has to compare with five elements. Again, when 203 I was comparing, earlier I was comparing with three elements. Now I have to compare with four elements, right? So as the number of input is increases, it will run loop more number of times, right? So let's see. So there are 10 iterations and I increased one more element. So if you see, now we have 15 iterations, right? It is not linear that if I increase one element, then only one operation will increase. No, let me increase one more. Right? Let's say 101. 101 is already there. That's fine. 1110. Right? Anything. So from 15, we will see it is going to 21. Right? So this kind of cases where you have loop under loop or you have a matrix, right? Let's say you have a matrix. Let's say 1, 2. So this is the first element of your matrix, second, third. Then you have, let's say, 4, 5, 6, right? And then 7, 8, 9, right? If you have a matrix n by n, right? And you have to loop over it, right? So three rows and three columns. So there will be nine elements, right? So it will be O n square. You will have to run your loop O n square. If you want to traverse over this matrix, then you have to run n into n times, right? So this is where your O n square comes into picture, and this is worse than your linear time complexity, right? Because in this, as the input size is increasing, this is increasing quadratic time, right? If you increase 3, then maybe it is 9. If it is 4, then it becomes 16, right? So your best is so far O1 because it is constant. Then you have ON and then ON square. The whole purpose of our Python programs will be that if we can solve our question with less time complexity. If we can solve this with O1, then great. If not, then ON. If not, then ON square. Most of the Python problems you want to solve with ON or O log n. Right? So we will see what is O log n, and then we will come back to it and we'll discuss the final thing. Okay, so what is O log n, right? O log n is a time complexity where the number of input size when you increase, then the number of operations also increase, but very very slow, right? It is not like on, that if you have, let's say, 10, then operations will be 10. If you have 10 size of your input data, then 10 operations. No, maybe if you have 10, it might be, let's say, 2 operations. When it is 100, then might be 6 operations, right? So it is logarithmic, which means as the input data size is increasing, this is also increasing, but very slow, right? So let's see how we can visualize this. Okay, so there's a concept of binary search, right? In SQL also, if you have learned index, you will know how binary search works. So how binary search works, let's say you have an array. I'm just explaining how this works, right? Let's say you have an array and it is sorted. Sorted means we know that it will be in a ascending order or descending order. So in our case, if you see, this is in ascending order: 1, 3, 5, 7, 8, 10, 13. So this is the requirement, right? That my array is sorted. Let's say my array is sorted. However we sorted it, it doesn't matter. But we are getting an array which is sorted. Now I want to find an element in this, right? One is we do a linear search, whatever we did here. We go to the each element and search it first, second, third, and wherever we find it, we are done. But because my data is sorted, I can do a binary search. Right? Now, what is binary search? Binary search means, let's say someone is telling me, so we have 7 elements in this, right? Someone is telling me that find where is, let's say, 3, or let's say 10. So I want the index of 10, right? So one way is linear search, we all know. But let's see how we can do with binary search. So what I will do, I will go to the mid of this array. So mid of this array is 7, right? Mid of this array is 7, and I will compare that if this element is equal to 7 or not, right? If it is not, then I will see if it is greater or less than my mid element. Now 10 is greater than my mid element. My mid element is 7 and 10 is greater than my mid element, which means 10 will be somewhere in the right? Because this is a sorted. So I'm checking with the mid element, my target element. I want to see where this 10. So I will check with the mid element 7, right? And 10 is greater than 7, which means that 10 will be somewhere in the right. So I can skip all these left element. I don't have to search. So I will search in 8, 10, 13. Again, I will take mid of it and I will check, okay, if 10 is equal to mid, yeah, mid is 10, so I will return that value, right? Let's take another example. Let's say 1. I want to search 1. So I will check with the mid element, right? If it is equal to mid element, I will return that. If it is, no. Now, if it is less or more, if it is less, then I will ignore these things. I'll just look into this. Great. Now, again, I will take mid. If it is equal, no. If it is less, then I will come here and then I will again compare. Then I will return this. Right. So basically, I'm doing a binary search, right? I'm not iterating over all the elements. I will just divide it, check with the mid element. Then every time my input size is becoming half and half and half, right? So let's take this example, right? So I've written this program for binary search. I'm not going to explain today. You can learn about it. But basically, let's see how many iterations we are doing, right? So I'm saying iteration 0 and iteration equal to iteration plus 1, same thing, right? And let's see how many iterations we will do. So I'm just running it. So if you see, it is doing the 3 iterations, right? I'm trying to find 1. My target element is 1, so it is returning 0, right? And 3 iterations it is doing. So I have 7 elements, iterations are 3. Great. Now let's add some more elements. It should be sorted. So I'll say, let's say 20, 21, 30, 33, 40, 50, 70. I just increased so many elements, right? So we had till 10, I think 7 were there. Now we have 1, 2, 3, 4, 5, 6, 7. Okay, I increased 1, 2, 3, 4, 5, 6, 7, 8. I added 8 more elements. So we have 15 elements now. And we will see how many iterations are happening to reach to see where is 1, right? I'll just run it. You see, only 4 iterations are happening. So input size increased almost double from 7 to 8, but iteration increased by only 1. Let's search for something else. Let's say I'm searching for 70, right? So if I search for 70, there are only 3 iterations, right? On the third iteration, it is able to find out, right? If I increase more, let's say 101, 102, 103, right? Again, it is just 2 iterations. It depends on where is your this element, but it will be increasing by very less number of operations are increasing because we are dividing into half, right? If there are 100 elements, we are dividing into 50 first, then 25, then 12, then 6, and then 3, and then 1, right? So we are not doing 100 operations, just we are doing a binary search, right? So you can think about something like this is your binary search, right? We look at the middle element. If my target element is less than middle element, I will go in the left. If my target element is greater than my middle element, I will go to the right, right? And then again, I will keep doing it until I find my final element, final target, right? So this is your log n. So capital O log n or logarithmic time complexity, right? So this is your log n. If you see, as the input data size is increasing, it is increasing but very slowly, right? As you have very big size 1 million, it is almost getting flat, right? So this is your logarithmic time complexity. Example is binary search, right? So there are other type of complexities as well, like 2n and factorial and all. But these are the main ones that we need to understand. And in fact, on square also we will be avoiding it most of the times. Right? Most of the times our solution should be in on. Right? I hope this makes sense. Now, last thing I want to tell, or two more things I want to tell is, one is when I sort something, right? So uh, let's go here, or it is fine. Let's go here. Let's say this is my array, right? Or this is my array transactions. Let me comment it. And I want to sort this array, right? So I will say transactions dot sort, right? And then I will say print transactions. Okay. And I will print again here. Okay. So let's see what will happen. So if you see, this is here. And now this is sorted. So 100, 101, 101, 1203 and all. Now this is inbuilt method of sort, right? But we need to understand that how much time it will take, right? What is the time complexity of this sorting? So when I'm doing a sorting, Python is doing some operations internally, yeah, right? There are different kind of sorting algorithm, right? But when we are doing this sort, this takes big O n log n time complexity, n log n. So this will be your n log n time complexity, which will be better than n square, right? But worse than on. So it will be somewhere here between o n log n, right? It will take more than n operations, but better than o n square. So your o n log n will be somewhere here. Right? So your this is how it is. So for example, if I want to find, let's say, largest element or smallest element in this transaction, right? So what I can do, I can sort it, and then if I want the smallest, I will take the first element, right? So I will say sort and then transaction 0. So my requirement is I want the smallest element in my array. So what I can do, I can do transaction dot sort, and then once it is sorted, then I will take the first element, and that will be my smallest element, right? So if I just run this, so this is my smallest element, right? But if you look at the time complexity, so this is O1, right? So to get the first element, it is O1, O1, right? But to sort it, it is O log n, n log n, right? So when we have two time complexities like this, that this is taking so we have two operations. One is taking O n log n and other one is taking O1. So we take the worst one, right? So the total time complexity, we will take it as O n log n for this program, right? Sorting plus getting the first element, the overall will be considered as O n log n, right? So if you have two operations, one with one time complexity, let's say it was on, and another n log n. So overall we will say n log n, right? So whatever is the worst, that one will be considered, right? So this problem we solve with O n log n. But can we make it better? Can we make this program so that it takes only one iteration and only can we solve it on, right? So we will solve this question next time in the next video. But basically, the idea is you should know that sorting is costlier than on. You should know that when you are sorting something, it is costly than on, right? So your on log n will be somewhere here. Okay, great. So hope you understand it. So generally people will just sort the data, right? And they will say, okay, I solved it. But if you can solve it without sorting with O n time complexity, that will be best. Great. Now last thing I want to discuss is dictionary, right? So when I do a lookup in a dictionary, so let's say I have my dictionary, sorry, let's say I'm saying employee ID and name, Ankit. So this is my key value pair, right? Another value pair is, let's say, 200, and value is Amit, right? Now this is my dictionary, right? Now when I do a lookup on a dictionary, basically let's say I want what is the name of ID 100. So I will say print my dictionary, right? And I will pass 100, right? Right. So let's run this. So if you say it is giving me Ankit, right? It is giving me Ankit. Let me comment this everything. Okay. So let's run this again. So if you see, I am getting Ankit. So what it is doing, we are doing a lookup. I am saying, give me the value of key 100. Right? This is my key value. Key value. Now you must be thinking that internally this is running a loop, right? Because it will go to first element and see if it is 100 or not. Then it will go to second element, then see if it is 100 or not. Then it will go to the third element. Let's say if they are 1 million. You must be thinking it may be doing a linear search, but that's not the case, right? When you do a lookup on a dictionary, it is a O1 time complexity. O1 constant. How? So what happens when you create a dictionary? It in memory, right, it has the all the values, which means Python will know that at what address in your memory 100 is, at what address 200 is. So when you say my dictionary 100, it will directly go to that address and give you the value. When you say 200, it already know, it has hashed all the keys, so it knows that 200 is where in your memory, right? So it will just go there and give you Amit, right? So this is a constant time complexity when you do a lookup on a dictionary, right? So this thing you have to remember, right? So any lookup on a dictionary is O1 constant time complexity. Great. I think this is all I wanted to discuss. Right now, when I solve questions, I will be able to, I will use these terms, right? Different kinds of time complexity, right? And then you should be able to understand it, right? Again, if you don't know the basics of Python yet, whatever I have done, if you don't understand those for loops, if else condition, then I think you should work on your core first and then you can follow my playlist, because that is the prerequisite. You can do any video on YouTube, learn from it, or we have a Python for data engineering course on Namaste SQL, whatever, wherever you want to learn, just learn it and then you can follow along me on this playlist. Okay, great. See you in the next video where we will solve some exciting and very conceptual Python questions. Thank you. Have a good day. Please do share this video with your friends and like the video. Have a great day.